Hi there, welcome to Cerp TV. I'm Dr. CPN. Hope I met you well. We have some problems here on the board to investigate their dimensional correctness, or what we call dimensional consistency. Now, the first one, I'm going to do number 1, number 2, and number 4, and I'll leave it up to you to do 3 and 5. Now, number 1 says we should investigate the dimensional consistency of this equation. So we begin with this one. By dimensional consistency, you are going to investigate every term. Now the dimensions for V, all cubed, is simply, the dimension for V is Lt to the minus 1. That's the velocity. Dimension for velocity is Lt to the minus 1, and then all cubed. And this simply becomes equal to L cubed, then T minus 1 times 3 gives me minus 3. So that's what is happening on the left hand side. Now let's investigate this term. The dimension for acceleration is simply equal to Lt to the minus 2. Dimension x is displacement. Now dimension for x is simply equal to L, and because it is cubed, so we simply have L cubed. Now what then becomes the dimension of these two terms on the right hand side? It simply becomes equal to Lt to the minus 2 multiplied by L cubed. And because, as a result of that, you now discover that this gives me L times L cubed is L to the power 4 T to the minus 2. And you discover that on the left hand side, the dimensions are not equal with those on the right hand side. So you simply discover that that equation is not dimensionally consistent or dimensionally correct. Now let's quickly look upon the second one. The second expression simply says that we should investigate the dimensional consistency of V. X is equal to, now we have x is equal to Vt plus half At squared. Dimension for x, I'm looking at this term now, we need to investigate them term by term. Dimension for x is simply equal to L. This is supposed to give me L2 if this is going to be dimensionally consistent. Dimensions for velocity is Lt to the minus 1. And of course, dimension for time is simply equal to, the dimension for time simply becomes equal to T. Therefore, if you combine these two and multiply them, dimensions for velocity multiplied by dimensions for time simply becomes equal to Lt to the minus 1 multiplied by T. And of course, T to the minus 1 times T is going to cancel out or give me 1. So L times 1 will simply give me L. Okay, now we come over to this other term. Of course, half is dimensionless. We normally do not consider constants and numbers in our dimensional analysis. So dimension for A is simply equal to Lt to the minus 2. Dimension for T all squared is simply equals to T squared. Then when you multiply the 2, you have Lt to the minus 2 multiplied by T squared. Of course, this simply becomes equal to Lt minus 2 plus 2 is going to give me T to the power 0, which of course gives me L. So you discover that each term in this particular equation has dimensions of L, number 1, number 2, and then number 3. So that equation is dimensionally correct. So we pick up number 4, and then I will leave number 3 and number 5 for you to do. So what exactly does number 4 say we should do? Number 4 says we should investigate the dimensional correctness of this equation. So we begin with the left hand side. Dimension for T is simply equal to T. Now what happens on the right hand side? Now you discover that square root of 2x all over a simply becomes equal to 2x a to the minus 1, because this a comes up, it becomes minus 1. Now all raised to the power of 1 over 2. Okay, so this becomes equal to 2 to the power 1 over 2. Is that okay? Then we now have x to the power 1 over 2, then a to the power minus 1 over 2. Of course, on my left hand side, I'm having t. So if I can find the dimensions of all this and come out with t, then the equation is dimensionally correct. So you now discover that 2 to the power half is a constant, so we don't consider it in dimensional analysis. So x to the power half, the dimensions, or let's put it this way, dimensions of x to the power half is simply equal to L to the power half. Now what about a to the minus 2? Dimensions of a to the minus 1 over 2 simply becomes equal to L t to the minus 2, all raised to the power minus 1 over 2. I hope you understand. Okay, good. Now this simply becomes equal to L to the minus 1 over 2. Now t minus 2 times minus half is going to give me 1. Minus 2 times minus half is going to give me 1. So I have t to the power 1. Beautiful. Okay, good. Now this becomes equal to L to the minus 1 over 2. Of course, you notice that there is L here to the power half multiplied by L to the power half multiplied by this t to the power 1. Now you now see that you now have L. By indices, we combine these two to get minus half plus half, then multiplied by t. And this simply minus half plus half is going to give me 1. Of course, it's going to give me 0. So I have L to the power 0 t, and which simply becomes equal to L to the power 0 gives me 1, and which gives me t. So you see that this expression or this equation is dimensionally correct. Please, I hope you have learned something from this video. If you did, please do well to subscribe to Cerp TV. Thank you very much, and see you in my next video. Bye-bye.